The Batman.
Okay, we're going to start with periodic functions today. We're going to actually go over all of the definitions for them. So this part's really important in order to really move on to sinusoidal functions, which is kind of our last definition here. Okay? So our objective today is we're just going to explore periodic behavior. And periodic behavior means behavior that repeats. So right now I've graphed something that has some type of repeating pattern. And it goes on forever. It doesn't seem to stop at all. It continues. So first thing we're going to talk about is a peak. Okay? You'll hear a lot about this in stock markets. Okay? And a peak is essentially the highest point in a periodic function. So the peak here in this periodic function is at what number? Anyone know?
1.
Yeah, we're looking at the number 1. Okay? This peak, it occurs over and over again, and there'll be many peaks, but the value of the peak itself is 1. That's the highest point on the y-axis. So we have our peak here, and I'm going to draw a line. Is that one dotted? So that's where our peak hits. That's the highest point. It continuously hits that point. We have to recognize what it is. Our second definition is our trough here. Okay? So that would be the lowest point. I was just doing that today. So our trough here, or the lowest point we're talking about, same idea as the peak, it's just the opposite. So the lowest point this sinusoidal or periodic function hits is -1. Okay? A period, which is the next thing we're going to talk about here, of this function refers to how long it takes for it to repeat its pattern. Okay? So the interval of the independent variable, our independent variable is always x, needed for repeating the action to complete a cycle. So what that means is you can actually start it anywhere. We're talking about specifically the x-axis. We're going to start right at the origin, at 0 itself. Okay? So we're going to say here's one of our lines. We'll draw it up here. We start at 0. And what we're looking for is how long it takes for us to return to that point in the same manner. Okay? Now that can be a little confusing. It's got to be that same point. Highlighter. So, now, okay, 180 degrees is a good estimate. It does definitely look like we get right back to this point again on the y-axis at 180. But the only difference here is before I hit it here, I was approaching it in an upwards fashion. When I get to 180, what's happening? We're going down. We need to approach it in the exact same manner as before. So it actually comes completely down and then back up to 360 again is when we complete an entire cycle. Okay? So our cycle takes 360, and since it's measured in degrees, 360 degrees to complete, which kind of makes sense. That's like what a circle is, right? So it takes 360 degrees to complete our cycle here, or our period.
Oh, because you start at the origin.
Yeah. And we approached it in the exact same way as before.
I don't get why we went
So that's what our period is considered. Cycles are things that continuously repeat. So a series of events that are regularly repeated, a complete set of changes starting from one point and returning to the same point in the same way. That's what we just talked about. Period and cycle are very, very similar. The only thing is we really only talk about one period of a function. You can talk about several cycles. For instance, if we take a look at this, we can point out at least 2 different cycles in this. We have the cycle I've drawn from the 2 highlighted. And if we go back a little, there's another cycle here. So we got 1, 2 different sets of cycles. Okay, so a cycle could consist of 2 periods. The 2 words are kind of interchangeable for what we're doing here. Okay, we're going to focus on the word period though. Just make sure you know what it means when your textbook asks you about a cycle. All right, equation of the axis. The equation of a horizontal line, this is an imaginary horizontal line, that is halfway between the max and the min, or the peak and the trough. So, what would be halfway between these lines? Our peak and our trough. 0. Yeah, so we have an imaginary line running through the middle. I'm going to highlight it. It's actually what? Anyone know?
0 degrees.
It's the x-axis, right? So our blue part here, that is our equation of the axis. And we would write that equation as y equals something. What would y equal in this case?
0.
That's right. So the equation of the axis is equal to, is y equals 0. Okay? So that's a line that goes horizontally straight through the middle of this equation. Or sorry, this graph. Now, a sine function. Sine function talks about our sine function from trig. And I've actually drawn what a sine wave looks like. Now, periodic functions can represent many different things. We could be talking about a Ferris wheel, or any type of circular object can be measured as a periodic function. What we're actually going to take a look at for the next, well, for a good chunk of this chapter, is sine waves. Okay, this is a sine function. So I've actually drawn a sine function, and what I mean by that is I'm going to try to relate it to a calculator so it makes sense to you guys. So 0, I plug in the number 0 and I hit sine, I get 0. So that's one of the coordinates on a sine function here. So I'm going to try to write the coordinates here in purple. One of them is at 0 and 0. I'm going to color that in so you can see it. Now there's many points in between 0 and 90. For instance, I already showed you guys 45 earlier. We'll do it again. 45 would be 0.7. It looks like that's about right. It's around 0.7. But there are 5 major points of a sine function or sine wave I want you guys to remember. Another one is at 90. Sine 90 gives us exactly the number 1. So what that means is, right here, we're at 90 degrees.
What would sine 180 be?
We're at 90 degrees. Okay, so back where we were. Another point on a sine wave that's extremely important is 90. So x is 90 and our y value is 1. So that's another major point. We can actually assign them numbers. Actually, we'll just leave it as this right now. 180. So looking at this graph, that coordinate is 180 and 0. We're going to actually test it out by putting it in a calculator. If I put 180 degrees and then hit sine, I get 0.
Oh, see word.
So there's another point. So if you're ever really stuck with sine waves or even cos waves, which I may eventually ask you about, you can kind of try to make sense of them by plugging numbers into a calculator. Another one we go with is 270. Okay? So an x is 270. What's our y value? It's right here. Negative 1. So let's try that out on our calculator. 270 degrees. Sine gives us negative 1. And finally, when we complete our period or our cycle, 360 is what?
0.
It's at 0. Good. And we can test it out. 360 sine is 0. Okay? So we've talked about sine functions, equation of the axis, the cycle, period, trough, peak, and sinusoidal functions is essentially sine x, and we'll go more into those a little later.